Hi, 8 Purple. I hope you're having another good day here in quarantine. Today's class is going to review the important latitudes that we went over yesterday and then introduce an online season simulator that I found that does a really good job of letting you play with a couple variables in regards to seasons. But first, before we get to that, I want to make sure that you watch until the end of today's video because there are some important instructions that I need to give you in order to get that online simulator working. So make sure that you listen until the whole thing. It should only be about 8 to 10 minutes. All right, so one of the things I wanted to go over today is this is the last question in the exit ticket from yesterday. Which of the following is not a reason for the seasons? So in my video, I did a pretty good job explaining why the tilt of the Earth, that fixed tilt towards Polaris, and the fact that the revolution around the Earth is what causes the seasons. But only 66% of you chose the right answer, which is that the distance from the Earth to the Sun has no impact on our seasons, and that's true. So make sure that you don't fall into this trap. The rest of you guys, the was this 24 of you or so that picked this one, make sure that you are aware that this is the reason. This has nothing to do with why we have seasons. Okay, skip over that. All right, so our important latitudes of Earth. So let's start up here. We have this pole going through Earth that is called the axis, and it is tilted at 23.5 degrees. Coming down off of that, that's also located at our poles, which would be 0 degrees north or 0 degrees south. I'm sorry, 90 degrees north or 90 degrees south, depending on if you're at the north or south pole. This latitude here, which is our first important latitude, that is the Arctic Circle, located at 66.5 degrees north. Coming down off of that one is the second black line that runs through the southern part of America and Florida right there, and the northern bit of Africa. That is the Tropic of Cancer at 23.5 degrees north. It is not a coincidence that this latitude is 23.5 and the tilt of our planet is 23.5, but we'll get into that connection in a couple of days. This line down here, everyone should be familiar with. That cuts right through the center of our planet, which is our equator at 0 degrees. The line below that is our Tropic of Capricorn, which is 23.5 degrees south. Again, there's a connection between this latitude and our tilt. And then down here, that's kind of hard to see and not pictured, is our Antarctic Circle at 66.5 degrees south. Our Earth, when looking from above, is going to spin counterclockwise as it rotates around the axis. This red line here, that one cuts right through New Canaan, and if you research that correctly, it would be at 41 degrees north. Okay, a couple of terms that I wanted to go over today. The first is celestial altitude. This refers to how high an object in the sky appears. So typically when you think of altitude, you're thinking about how tall a building or a tree or a tower might be, and that's measured in distance from the planet's surface to the top of that object. But with stars and celestial bodies that move across the sky, you can't really do that. A, because the distances are tremendous, so it doesn't really make a difference how far you're talking. And B, these objects change as the Earth spins, or the altitude of these objects, or the apparent altitude changes as the Earth spins. So for example, when the sun first rises in the east, it's very low in the sky, so it has a low altitude. And then throughout the day, as the Earth is spinning, the sun appears to get higher and higher and higher until it reaches a maximum point, and then it gets lower again. And that happens for virtually every single object in the sky, be it a star, a planet, or something else. The zenith or zenith refers to the highest point reached by an object in the sky. So every day as the Earth rotates, every object in the sky will reach a maximum point, and that's that object's zenith. The highest possible altitude any object can reach is directly overhead, which would be 90 degrees. So you can't have a celestial altitude greater than 90 degrees. If you do, that just means that it's coming back down the other side. Throughout the year, the sun's apparent altitude changes and it gets higher and lower on its path across the sky. So if you're standing here, if you're in this cluster of buildings, and you're looking south, the sun would rise in the east, come across the sky, and then set in the west like that. And the path that it takes is totally dependent on the time of year. So in the wintertime, that path is very low. It rises in the south, kind of just south of east, and it gets higher and higher and higher, but it doesn't get all that high. And it starts getting lower and lower and lower and sets just south of due west. In the summertime, however, that path is much, much higher. So it rises north of due east, and it gets to a very high point in the sky, maybe not 90 degrees directly overhead, but it gets very high, and then sets just north of due west. And then throughout the spring and the fall, that path just goes this way or this way. The sun gets kind of, it moves in between these two extremes. This is what that sun would look like every day. This is what that sun would look like at high altitudes. So it would last the entire day, the entire 24-hour period, and it would never set. So what you're looking at right now, this would be noon at its maximum point, and then it comes down, and at a minimum, that's midnight. So here's our daytime, noon, afternoon, evening, good night, midnight, good morning. So that's how that would work. It's kind of this neat little pattern that happens at specific times of the year. Another neat pattern that shows itself is something called an analemma. An analemma is, if you were to take a picture of the sun at the same time of day, every day for a year, or maybe once a week or something like that, it would make this interesting pattern in the sky. So here's that path again. So right now our viewpoint is we're looking east, and so the sun would rise in the east, and it's not going to come straight up east and stay due east. It's going to rise north of east, like I said previously, in the summertime, and it will rise south of east in the wintertime, and it takes these paths across the sky. So if you were to take a picture at, say, 8 a.m., and you were in Washington, D.C., the sun would have this shape. It would make this shape throughout the entire year process of making that picture. This is what the end result of that would look like. So this is about 52 pictures. I didn't count the dots, but it looks like one a week. 52 pictures of the sun at the same time of day, taken at the same location. Okay, so for the rest of class, I'm going to have you guys watch this really good video that explains the seasons by Rebecca Kaplan. It's a TED Ed talk, and she's from this area. I think she's from Connecticut, so her talk is very relevant, and she uses examples from Connecticut. I'll link that video in the Google Classroom, and I also have a link to something that is really cool. It's an online season simulator, but it uses Flash. So let me give you some tips on how to get that working. First, here is how you get to it. Well, the link will be in the Google Classroom, but if you want to search for it, it's Astronap Season Simulator. And it's usually the first one that comes up. And it looks like this. So this is what happens if everything works, but typically for most students, there'll just be a gray box here with nothing. But that's because you have Flash disabled. So in order to enable Flash, you can do this for any browser, but the example I'm going to give is for Chrome, so you probably want to be using Chrome for today's class. Go to this little lock box up here, this padlock, click on that, and then come down to the site settings. Click on the site settings, and that will allow you to adjust this option for Flash. Now, I'm working on a school computer that I borrowed from school, so this is actually set by our tech team, our administrators, so I don't have access to change it, but you should because you're working on a personal computer. Luckily, mine is already on allowed, but I don't know if yours is going to be allowed or blocked. But either way, you want to allow Flash and then go back to the season simulator, refresh it, and it should work. And then once you get it working, you can play with a couple of different variables about how the sun changes in terms of its intensity throughout the year by playing with these variables. Okay, thank you for watching, and please let me know if you have any questions.